It is the highest mountain in the Alps. But deep inside the icy slopes of Mont Blanc are hidden lakes. A secret water world that is stunningly beautiful, but deadly. 100 years ago, one of the mountain's hidden lakes burst forth, sending a wave crashing down toward the villages below. Nearly 200 victims were caught by surprise, unable to outrun the flood. 2 days later, rescuers were still plucking bodies from the mud. Dozens were found inside buildings, ripped open by the deluge. The chapel, which was damaged but survives today, bears witness to the horrors that took place. Here, historian Jean-Paul Gay looks for clues to a tragedy that no one fully understands. Ice experts have also come to solve this 100-year-old mystery. They try to gauge the internal forces of the ice to predict when the next flood will occur. They're descending into frontiers never explored.
C'est un risque inconnu, complètement inconnu.
It's an unknown risk that could kill people if a hidden lake were to empty all at once.
It may be only a matter of time before Mont Blanc faces another disaster. Descent into the ice. Up next on Nova.
Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support Nova.
We see an inventor. At Microsoft, your potential inspires us to create software that helps you reach it. Your potential, our passion.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Mont Blanc towers above Europe, the apex of France, Switzerland, and Italy. But after 200 years of exploration, this mountain is still untamed. It's a vertical landscape where ice laid down in the last ice age carves a path through sheer bedrock. These frozen rivers are known as glaciers, but their uneven surfaces filled with teetering ice blocks only suggest the greater dangers that lie within. Luc Moreau is a glaciologist who lives and works on Mont Blanc. He knows the mountain inside and out.
We are facing one of the great natural wonders of the planet. This mountain makes you realize just how small we humans really are. It's alive, ever-changing, always surprising.
C'est vivant.
Luke is joined by Carsten Peter, an ice climber from Germany, who travels the extreme landscapes of the globe, exploring, photographing, and mapping the world's most extraordinary ice caves, some of which are found here. They're searching for a specific ice cave that the French call a moulin, a water well or deep shaft formed by flowing meltwater on the surface of the ice. Their goal is to descend into this water and penetrate as far as they can go to search for a hidden lake. No one knows how deep, how large, how destructive these hidden lakes can be, or how many there are. They land on France's largest glacier, the 7-mile-long Mer de Glace, to conduct their research. Today, Luke and Carsten will make their first descent below the slick surface of the glacier to the waters deep within. They'll camp on the ice for several days, but it's not exactly roughing it. Their food has been flown in by helicopter. Meals are orchestrated by Luke's wife, Evelyne, a professional chef. Luke calls himself a glacianaut. He's well aware of the risks.
Here we have two kinds of risks. First, there are subjective dangers, based on the skill of the climber. Then there are objective dangers from the environment itself. To minimize those risks, we've adopted some precautions taken by cavers with crampons, ice axes, ice screws, and a helmet. Because once you're inside, there could be ice or falling rock, rushing water, so we need to be always totally alert.
60 feet wide at its mouth, the water well is a vertical cave, tunneling 85 feet down to a deep reservoir fed by 2 waterfalls. From here, we see the inner workings of a glacier. 70,000 years ago, one large ice cap covered most of the mountain. But now, Mont Blanc has about a dozen smaller glaciers that change with the seasons. Since the last ice age, Mont Blanc's glaciers have grown several times. But today, they are receding due to climate change. Small fluctuations in the size of a glacier can cause avalanches, mudslides, and icefall, endangering the towns and villages below. But the ultimate danger may be from a hidden lake. They are undetectable under the ice, and the only way to find one is to travel inside the glacier as far as is humanly possible. On the Mer de Glace, the ice is 1,000 feet thick. Glaciers grow from the accumulation of snow, which transforms into ice and slides downhill under its own weight. The snow melts under the sun's rays, and the meltwater circulates down through cracks and crevasses. On some glaciers, water will find a fault in the surface and plunge downward through the weakness, carving out a deep shaft. These are water wells, and they act as the starting point for tunnels of meltwater that flow inside the glacier. Having descended into the water well, Luke can see how quickly the meltwater is chiseling into the ice. Over time, the ice shaft will change shape according to the temperature of the water and the strength of the ice. Today, remarkably, both the ice and water are the same temperature. With the ice close to its melting point, it is unstable and dangerous to climb.
On a de la glace qui est à 0 degré de température.
Here the ice is 0 degrees centigrade.
Quelques semaines plus
It's
tard,
not cold ice, we call it temperate ice, that will change its shape with the inflow of water. Over time, the water well will enlarge, the ice will become pitted, and the reservoir may fill up completely. We're lucky to be able to explore this cavity, because it's changing every day.
ça évolue très rapidement.
Depending on the temperature of the ice, the walls they're climbing can vary from the hardness of concrete to the softness of wood, where ice tools can easily come loose. At the surface of the water, they decide to venture further into a small tunnel to see if it leads to a hidden lake. They have to wait until nightfall to continue their climb deeper into the ice. Luke and Karsten enter the tunnel, 85 feet below the surface of the glacier. In the cold evening temperatures, there's less danger of the glacier collapsing on top of them, and less chance of a surge of water bursting through the tunnel, drowning them inside. They risk capsizing in their inflatable raft. It has to be small to fit, and the weight of 2 men inside is precarious. Falling in these waters would result in hypothermia, so they've fixed ropes to the ice for stability. This journey is the closest they'll come to understanding the dynamics of the innermost depths of a glacier where hidden lakes are most likely to form.
C'est le risque glaciaire le plus inconnu aujourd'hui.
The hidden lakes are the least known danger that we face today from a glacier. We have very little information about the danger because it's so hard to penetrate within the glacier. This water well is the only way to see the interior of a glacier. We can see how water circulates, how it's held back. Is it always flowing? We are not sheltered from a hidden lake bursting. They're impossible to detect, impossible to predict.
Impossible à prévoir.
They travel over 250 feet into the glacier, further than anyone has gone before. And they have no idea what lies ahead. Luke is looking for signs of a hidden lake, held in place by a barrier of ice. 100 years ago, the barrier burst. And millions of cubic feet of water cascaded down the mountain, drowning the villages below. The thermal baths in nearby Saint-Gervais was where the greatest loss of life occurred. Visiting the now rebuilt spa, historian Jean-Paul Gay has pieced together the moments that led up to the deadly flood.
En
It's 1892 in early July, and there are 300 people staying here. Spa guests, but also staff, caterers, chambermaids. It's like a little town down at the bottom of this gorge. They're getting ready for a nice evening at the resort. A pianist has come from Geneva to give a concert that evening. It's a place where people come for treatment. They come to enjoy the waters. In the 19th century, people ate a lot in France. They liked good meals, and of course this played havoc with their health. And so every year they would come for 2 or 3 weeks for the waters of Saint-Gervais. They would drink the water, they would take baths, they would take showers to try to improve their health.
July 11th was a very hot day, and the spa guests sought out ways to cool themselves off at a nearby waterfall.
The waterfall played an important role on the night of the catastrophe because, as you see, the gorge is very narrow, very enclosed. When a hidden lake burst from a glacier, a dam formed. The gorge was blocked by boulders and fallen trees. The debris could no longer move. Water built up behind it, thousands of cubic feet of water.
In a split second, the dam of debris dislodged, sending a wall of horror down upon the resort, smashing the buildings to pieces. A wave of suffocating mud enveloped the lower floors of the spa, and it all happened without warning.
All of this takes place in the dark of night. They have no idea what is happening to them. The people would have simply been crippled with fear.
The roar of the floodwaters sent panicked villagers running for higher ground. They were the lucky ones who were among the living at dawn. One woman, swept downriver, saved herself from the mud by grabbing onto the balcony of a collapsing house. It took 2 days for victims' bodies to be recovered. Some were washed down to Lake Geneva, 50 miles away. Many were never found. In the village of Bionnet, 9 houses and their 33 inhabitants were swept away. The schoolhouse still stands today, but many of the pupils at home that night in bed were drowned. We know who they are because the original school register was found by Jean-Paul Gay.
Typically, what is written here is, she finished school and went on to university. He left to work in the fields with his parents. But here, on that date, you can see, she died in a catastrophe of the 12th of July. There are 4 kids on this page. I can see Victorine Bouchard, who was born in 1886, 7th of August. Her father was a farmer in Bionnet. So she was 6 when she died in the catastrophe. And then we can see another child by the name of Bouchard, and indeed, it's her brother. His name was Henri, who was 3 years older. So there you have it, a brother and a sister who died. 8 from this school lost their lives in the catastrophe.
The loss of so many lives begs the obvious question: might a catastrophe of such enormous magnitude happen again? The only way to know is to search beneath the glacier for hidden lakes. On the Mer de Glace, Karsten descends into the water well to see if it will be possible to do an exploratory dive. They've followed one tunnel at the surface of the water. Now they plan to go much deeper to look for underwater tunnels that could lead to a hidden lake. Karsten rigs a digital video system on an extended arm to submerge underwater to test the visibility. He wears special goggles that project the recorded image onto the lenses before his eyes. Like a virtual reality video game, he can manipulate the camera without succumbing to the icy water himself. Before doing a real dive, Karsten needs to know how clear the water is and make sure that there are no large cracks that could suck him unwittingly into the glacier.
For me, it's just another world. To dive into another world, you can't see it from the outside exactly. How, for example, the visibility is, how the crystals, how the formations, how the whole situation is. So it was good to have this preview with a remote DV cam just to judge if the effort of a diving expedition is justified.
Luke descends. With a rock attached to a rope to measure the depth of the water well. This will help Karsten gauge how deep he should be prepared to dive. The weight of the rock should be enough to anchor the rope to the bottom of the shaft.
Well, it looks very, very deep.
The rock hits bottom, and Luke marks the surface level with red tape.
meters.
24 meters, or 80 feet, means this will be a deep water dive for Karsten. It's the moment of truth. The water well is as safe as it will ever be for a dive.
Be careful.
It's just cold enough to keep the glacier frozen, and the water well hasn't yet turned to ice.
We made a depth measurement. It could be even deeper than 23, 24 meters. The water is quite clear, and for me it's the first time in the Alps to find these beautiful conditions.
Armed with this information, they leave the water well, determined to return as soon as they can with their scuba gear to take advantage of the perfect diving conditions before temperatures drop. But in the meantime, Luke has a job to do. It's his responsibility to monitor the ice all over Mont Blanc. The towns below hire him to watch for unexpected surges of water coming from within the glaciers. His commute is one of the most beautiful on Earth. He takes a gondola to an elevation of almost 7,000 feet. His dog Poppy, a husky mix, is always at his side as he ascends to the Argentière Glacier, the second largest in France. But he'll see this glacier from the inside out.
Quand j'étais petit, mes parents m'avaient fait visiter la grotte de la mer de glace.
When I was a kid, my parents took me to visit a cave underneath the Mer de Glace, a popular tourist attraction. And I have to tell you that I remember it vividly. It was pretty surreal being inside a glacier.
C'est aussi un environnement.
This is an environment that makes me appreciate the frailty of man versus the power of nature.
Par rapport à la nature.
Luke works for a hydroelectric company, which has built one of the only underglacier labs in the world. Here, a labyrinth of man-made tunnels extends deep inside the glacier. 35 shafts that harness the glacial meltwater for power.
Le mouvement.
My work here is to measure the movement of the glacier and determine exactly where the water flows. The water is collected underneath this icefall, and then channeled to fill a reservoir down valley, which produces electricity. As there are so few sites like this in the world, it's very useful for original research.
Luke and Poppy have to climb over 600 steps each day to get to the heart of the glacier. Just when one flight is done, another appears at the end of a long tunnel. And finally, a large cavity beneath the ice where a river of melted ice flows over the bedrock. Above Luke is the glacier, 350 feet thick. Here, Luke can measure the movement of the ice with a bicycle wheel mounted on a cantilever. By speeding up his video record, we can see 5 months worth of ice flow.
Le glacier est en mouvement.
As the glacier slides down the mountain, it spins the wheel. It moves 2 feet per day, or about an inch an hour. To my knowledge, it's the only instrument that can measure the movement of a glacier from below. Since this is electronic instrumentation, and there's all of this sand and water, we have to check the equipment regularly. It's an extreme environment.
The wheel is wired to an instrument that plots the speed of the glacier.
We're able to see that in summer the glacier moves faster than in winter. That's because the increased meltwater acts as a lubricant.
Luke can also measure the amount of water flowing under the glacier and detect any abnormalities in its flow. If a hidden lake were to burst, his instruments would pick up the increase in volume and warn the village below of a possible flood. It's rare that a glacier can be monitored so closely. Using a fixed camera mounted 650 feet from the ice, Luke has created a one-of-a-kind movie of a glacier as it moves over the course of a year. One valley to the south lies Mont Blanc's greatest glacier, the Mer de Glace, the Sea of Ice. Waves of crevasses and undulating ice bands churn up the bedrock below, making the glacier look dirty and gray. At this time of year, any surface water is frozen solid, except at the Moulin, the water well that Luke and Karsten explored. The team flies in their specialized gear for what will be a technically challenging dive at high altitude and in extreme cold. They'll use a combination of cave diving and cold water diving equipment. A single diver's rig weighs 132 pounds. Karsten is undergoing considerable risk in a new attempt to find evidence of Mont Blanc's hidden lakes. They return to see that winter has set in. A dive here seems improbable. The recent snows have accumulated in the water well. Luke will have to figure out how deep the snow is and whether he can even stand on its surface without falling through.
2 meters.
He's clipped into an anchored rope so he can be pulled out in case he breaks through the snow into the water below. They're trying to figure out the best place to dig out a hole for the dive. Snow gives way to a layer of ice, but no one knows how thick it is. Luke's chainsaw will be the quickest way of cutting through to an answer. He has to be careful not to flood the motor. The goal is to make a hole wide enough to enter. One layer of ice leads to another 3 feet below. And hopefully it's the last. Diving inside a glacier at 11,000 feet is a risk, but it's the only possible way of locating a hidden lake. To beat the sub-freezing temperatures, they work into the night. And finally succeed in cutting a 5-foot-wide hole. Karsten shines a light underwater to check the conditions. It's an eerie sight, a frigid pool with just enough visibility for Karsten and his 2 diving assistants to enter in the morning. Dawn brings with it a strange sight. Men in diving suits, wearing crampons while rappelling into an ice shaft high in the Alps. This will be the first underwater dive ever done on Mont Blanc.
It will be a little process now to bring all the luggage down. So we have very heavy diving equipment. Some of these equipments, they weigh more than 50, close to 60 kilograms. So it's really a hard work first. Okay.
Tire un peu.
Okay.
The heavy tanks are lowered down first. They're handled carefully because gas under pressure can be highly explosive. The depth of the water requires them to breathe nitrox.
We dive here with nitrox. This is a mixture, an enriched mixture. At a certain pressure, the oxygen becomes toxic, and so you have to beware. You have to have a diving plan, and you have to behave according to your mixture.
The mixture has more oxygen than nitrogen to reduce the time they'll need to spend on their way back up to the surface decompressing after the dive. Zinc oxide applied to the skin acts as a natural insulator.
Do they have hot water here, Luc?
Yes.
Yeah.
Karsten's mask has already iced up on the inside, which will make visibility impossible.
It's already frozen. And every little thing will freeze now, I think. Okay, just let it melt, yeah. Okay.
They wear special dry suits for freezing temperatures.
The dry suit is absolutely necessary in these temperatures. So you are, as the name says, the inside is dry.
Now it's fixed.
Okay. We cannot inflate our dry suit with the nitrox because it's too oxygen rich, and if we dive with the artificial fibers it could incend, and the oxygen could burn the fiber inside. So we need another gas, it's argon, just to inflate the dry suit. You press here on the suit and the argon is inflated here. This is the deflator. Okay.
Argon is also an excellent insulator against cold. The water temperature is at its freezing point, so the biggest danger is that their regulators, or air valves, will freeze shut.
Here we are close to the freezing temperature, and if compressed gas expands, it cools down. And so the danger of icing is very, very big. So probably our regulators will be blocked. So if we are now in a depth like 20, 30 meters and the regulator is blocked, we have to change, of course. We have two independent systems, but even the two independent systems could block. So it's very important to have assistance with other divers. So I brought two friends with me, and it's a very serious dive. So it's less risky to do it with experienced divers.
One of Karsten's regulators has already iced up. A regulator that's frozen open will allow all the precious air needed for the dive to escape. Karsten will use the rope as a lifeline to find his way back up. He descends into the water well to take an initial look.
The first impression, it's quite big and you can't see to the end, and it's easy to lose orientation. So we have to be very, very careful for the dive. Very careful. Safety is very important. Can someone bring my video camera? Put it here on the... Okay, thank you.
Karsten's companion divers have done extensive dives in extreme cold. Their combined experience will be the greatest guarantee of safety. But their regulators keep freezing open, with gas leaking out before they've even looked below the surface. Each diver has a lifeline to follow as they descend into the unknown. The visibility is marginal due to a high concentration of ice crystals mixed into the water. One of Karsten's assistants checks his handheld thermometer and records a water temperature of -0.7 degrees Celsius. It's remarkable that the temperature is actually below freezing in a pool of water. They're suspended in the balance where glacial waters lie between liquid and ice. What they're seeing is a cross-section of glacial ice. The white walls are frozen snow with air bubbles, and the dark striations represent pure water that has frozen solid. They're looking for cracks or tunnels where the water might be escaping from the shaft. From where they are now, close to the bottom of the water well, the fear is that a slight movement of the glacier or crack in the ice could open up tunnels that will suck them into the glacier. A wrist compass helps prevent disorientation in the murky water, and a sketch pad is used to map the shape of the water well. It looks like it's completely closed, simulating what a hidden lake would look like, but much smaller. It's an entirely new perspective on what lies within the glacier.
Quand on essaye de comprendre les mécanismes des glaciers,
if you want to understand how a glacier behaves, it's important to spend the time observing them, measuring them.
La surveillance, l'observation, les mesures.
We are lucky to be studying a phenomenon still not well understood.
But formations like this are not permanent. As the glacier shifts, small cracks could appear, and over time the water would drain out. But something much more powerful happened in Saint-Gervais 100 years ago, when the ice walls surrounding an enormous hidden lake burst, releasing millions of cubic feet of water. But today, all is well. Like a jacuzzi in the ice, the bubbles are a reassuring sign, unless frozen regulators are leaking excess gas.
80 feet, that's quite deep.
Their dive plan has reached its time limit. They have to come to the surface now or succumb to decompression sickness.
On a l'impression qu'ils sont arrêtés à...
It looks as though they've stopped 10 feet below the surface. If they went all the way to the bottom, beyond 60 feet, they'd have to come up slowly and make decompression stops.
Karsten surfaces first, and it's clear that he's using his backup regulator as the other one leaks loudly.
Can you please close the bottles? Okay. Okay. Oh shit. Probably I froze my lips. I had ice in my mouth. Ooh.
Karsten's lips, the only part of his body exposed to the icy water, are frozen, and he's worried he has frostbite.
Okay. Mark, everything okay?
Yeah.
Bei dir? Ist alles okay?
Argonautomat.
He's the only one who is okay, but he has similar problems too.
With 6 regulators among the 3 of them, only one remained as backup by the end of the dive. The team has gone where no one has been before, diving in a frigid pool of water 80 feet beneath the ice. They found no cracks or tunnels, and they still don't know whether there could be a hidden lake further inside the glacier. There is one other way to find out. But they'll have to return when the weather is warmer and the meltwater on the glacier starts flowing again. To the untrained eye, the difference is almost undetectable as winter releases its hold on the Mer de Glace and the relative warmth of summer arrives. The glacier is melting again, and surface water has carved a deep canyon that leads to the water well, still plugged with the winter's snow. Luke and Karsten are back to conduct an experiment to determine how long it takes water from here to flow to the base of the glacier. Luke is just above the water well, and Karsten at the glacier's end, where water flows out some 2.5 miles down valley.
Okay, let's compare our watches. What is your time exactly?
2:25.
Okay, copy. 2:25.
Are you ready for coloration?
I am ready to put the color in the river.
Luke pours several tablespoons of fluorescein, a high-concentration pink fluorescent dye, into the water.
A tiny amount of this substance can color a huge amount of water. So we look for any coloration in the water pouring out of the glacier at the bottom a few miles down, where Karsten is now waiting. So we will measure the time it took the water to cover that distance.
If the colored water doesn't emerge at the base of the glacier, there could be a blockage, possibly a hidden lake.
So Karsten, now the coloration is in the river, so approximately between 2 and 3 hours to the front of the glacier.
Okay, I'm prepared for a long afternoon.
Là, en fait, on voit que... La dernière fois qu'il y a eu une opération de ce type,
The last time this experiment was performed was 100 years ago, when they found it took 2 hours for the water to travel from here to the bottom of the glacier.
et le front du glacier.
Glaciologists were able to show that water takes twice as long to travel inside the glacier than it would in an open stream.
Sous les glaciers.
Ah.
Okay, have a good day.
Thank you.
Karsten, are you okay, or do you see something?
Oh yeah, I'm very attentive. No, nothing so far.
Okay, so you call me when you see something.
Not knowing if a huge pocket of water is forming inside a glacier that hangs above a village is unnerving for Luc and the communities that live around Mont Blanc. Uncertainty is something that ice experts have to live with, and there's no way of knowing whether the 1892 disaster at Saint-Gervais was the last of its kind. At the time, scientists and rescuers did everything they could. The very next day, alpine guides from Chamonix were up at the outburst point, and what they found was astonishing. A hole left by the explosion of the hidden lake out of the front of the glacier. When the water drained out all at once, the roof of ice over the hidden lake collapsed, leaving a perfectly round sinkhole in the ice. Scientists then spent years examining the glacier and came up with a solution to try to prevent the disaster from happening again. 2 drainage shafts were driven through the mountain to relieve the ice of any trapped water. The drainage shafts are still maintained. Ice is scraped out of the tunnel every 5 years, so water can easily flow out of the glacier in the warm summer months and be diverted away from the towns below. But no town in the Alps is completely safe. Small pockets of water burst all the time, and there's no way to rule out the threat of larger, potentially damaging hidden lakes. The best safety measure would be to find a way to predict where they are, as Luc and Karsten are trying to do.
Look for Karsten, look for Karsten.
Yes, Karsten?
The color is arriving.
Yes, super, perfect, Karsten.
The dye takes 2.5 hours to reach Karsten, and the speed indicates that there's probably no hidden lake to obstruct the flow, at least for now. Having completed their research, Luc and Karsten rope up to climb the last 5,000 vertical feet to Mont Blanc's summit. Luc has been there twice, but Karsten has never had the opportunity to climb the mountain. They start from the Mer de Glace. And take a route that travels directly up the glacier. passing giant ice blocks, caves, and formations caused by the rays of the summer sun. Rising head and shoulders above the surrounding Alps, the snows of Mont Blanc are becoming increasingly unpredictable. As global temperatures rise, no one can say with certainty what will happen to the glaciers and what effect climate change will have on the hidden lakes within.
If we had all the scientific tools to detect a hidden lake, it would be very useful. Because hidden lakes are the most unknown phenomenon in the Alps. Luckily, they're very rare. So today it's not a huge risk, but it's an unknown risk that could kill people if it were really a hidden lake that emptied all at once. Because there's a lot of people downstream from the glacier. If we could see it, we could better understand the phenomenon, how it's created, how it evolves, and then how it can become a hazard.
In this quest for understanding, scientists push themselves to the limit. They explore the tunnels formed by rushing water deep within a glacier. They penetrate down to the bedrock in man-made shafts to plot the speed of slowly moving ice. It's a dangerous business, and no one knows whether it will solve the mystery of the unpredictable waters of Mont Blanc.
Superbe, hein? Super.
Over 300 people will reach the summit with Karsten and Luc today. A reminder that greater numbers are visiting Mont Blanc. The sudden rupture of a hidden lake could affect greater numbers of people than ever before.
Glacial hazards take many forms. On NOVA's website, see satellite images of a lake forming high on an Italian glacier, an avalanche that buried a Russian village, and more. Find it on pbs.org. To order this show or any other NOVA program for $19.95 plus shipping and handling, call WGBH Boston Video at 1-800-255-9424. NOVA is a production of WGBH Boston. Major funding for NOVA is provided by the Park Foundation, dedicated to education and quality television.
We see Teacher of the Year. We see kids reaching their potential. It's what inspires us to create software that helps you reach yours.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support NOVA.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
We are PBS.